Okay, this is Chapter 3, Objective 2 continued. So we're going to be doing a mean value theorem. So I'm going to give you a second here to write before I start reading it. And then this should be something that goes into your note cards because we will be referring to it all year, or certainly in AP review time as well. So this is a lot like Rolle's theorem in that we have that verify step. So we have to make sure our function is continuous and differentiable, like that's part of what we have to do, so that's the verification portion. So we will check for continuity and we'll check for differentiability, just like we did for Rolle's theorem. What's different though is we don't have to make sure the endpoints are the same, but there is guaranteed some C value in the open interval, so that means C cannot be an endpoint, so C is in the open interval, where the derivative at C, so that would be the slope of the tangent line, is equal to f of b minus f of a all over b minus a. So this right here is referring to the slope of the tangent line, and so what is this referring to? Okay, so we're just going to do a little drawing off to the side here. So I'm just going to do a random graph, and I'm going to pick 2 points, so A and B. So I'm going to say this is point A, and we'll say that's point B. So when I do f of b minus f of a, this is a change in y, right? So I'm finding the change in y values. And then when I subtract b and a, then that's finding me the change in x values. So if I'm finding the change in y over the change in x, I'm looking for the slope between 2 points on this graph, right? So I'm looking for what is the slope between any 2 points on this graph, so from A to B. So let me connect that. So if you remember this, when you cross through from your geometry days, that was called the slope of your secant line, right, or your secant line. And then your tangent line has to be equal, right? So I'm looking for where is the slope of the tangent equal to the slope of the secant. So this portion right here is finding me the slope of the tangent line, right? We take a derivative and evaluate it at C. And where is that running parallel? So where is that slope equal to the slope of my secant line? So A and B. So this is just trying to give you a visual so that you can see what they're asking for. So the mean value theorem is we're looking for where is the slope of my tangent equal to the slope of my secant line. And we'll have to solve and do that math. So we'll have to go back to our days of how do we find the slope of a line. We just do change in y over change in x, so we can do that. And then compare that to my derivative, and that's what we're going to do. Okay, so this next portion you don't need to write down, is just something for us to talk about. So when we talk about the mean, so from the mean value theorem, it refers to the average rate of change, and we use rate of change often, so we're going to abbreviate that as ROC. So the mean above refers to the average rate of change of f in the interval from A to B. So this is our average rate of change. And then geometrically, the theorem guarantees the existence of a tangent line, right here, that runs parallel to the secant line through the points A, f of a, so that would be this ordered pair, A and f of a, and B, f of b. And again, you don't need to write that part down. And so in terms of the rate of change, ROC, the mean value theorem implies that there must be a point at which the instantaneous rate of change is equal to the average rate of change. And so this part I do want you to write down. So that is referring to the mean value theorem. So our instantaneous rate of change, which is our f prime of c, and so you can write that as ROC, is equal, so this part is my instantaneous rate of change, equal to the average rate of change, and that is just the slope, so the change in y over the change in x. So the instantaneous ROC equals the average ROC. Okay, and then let's go ahead and do an example. So go ahead and write the example down. Okay, so I'm going to do my steps over here. And then I'll do my work over here. Okay, so for my steps, I know the first thing I need to do is verify. So this is a lot like Rolle's theorem. It's just easier though. And then I just have to check for, is f continuous? And then is f differentiable? So that's my first step. And I always want to label like this is what I'm doing, I'm verifying. So over here in my work, I'm going to show my verify step, and I'm going to call it verify. So when I look at my function up here, I see that I'm dividing by x plus 1. So that means my function is discontinuous at x equals -1. So I'm discontinuous at -1 because I don't want to divide by 0. It also means I won't be differentiable at -1 because when I took this derivative, if I were to do that, I would get low d high minus high d low all over the square of what's below. So I would still have this in my denominator. So it would also not be differentiable at -1. So discontinuous at -1 and not differentiable at -1 because it's discontinuous there as well. But when I look at my interval, -1 is not on my interval, so then this is not important. So if my interval went from, say, -2 to 2, I would just say mean value theorem does not apply, and I would be finished. But here, -1 is not part of my interval, so then that's okay. So then, even though I'm discontinuous, my function is continuous, though, on my interval. So then what I would need to say is that f is continuous on the closed interval from -1/2 to 2, and it is also differentiable on the open interval from -1/2 to 2. Okay, so this part over here being -1 in the denominator doesn't apply to my problem because of my interval. So that's my first step. And then my second step is I want to find the slope of my secant line. Okay, so I want to find the slope of my secant line. So I want to do this portion first. So I'm going to do f of b minus f of a over b minus a. So now I'm going to, in the solve portion. So if I look up here, this is my value for A and my value for B. So I'm going to substitute 2 in. So I will get, I'm going to write ms, so slope of secant. So f of 2 minus f of A all over B minus A. Okay, now I'm going to give you guys a second to try to solve for that. So replace 2 into here and -1/2 into here, and then see if you can figure that out. Okay, so when I replaced 2 in up here, you should have gotten 2/3. And then when you replace -1/2 in, you should have gotten a -1, so that would be a +1. And then 2 plus 1/2 is 5/2. And then hopefully when you did the math here, you ended up with 2/3. Okay? So if you didn't get 2/3, just go back and look to kind of see maybe where did you add something wrong or subtract something. Okay? Okay, so now that I have the slope of my secant line, I'm going to set that equal to my derivative. So I'm going to find f prime of x and then equal it to 2/3, which is the slope of the secant line. Okay, so let me write that here. Okay, so we have to do quotient rules. So low d high minus high d low. So you guys do that part. So find your derivative. And then after you do low d high minus high d low all over the square of what's below, go ahead and simplify it a little bit because we'll need to solve this equation. So low and then d high minus high d low all over the square of what's below. And so when you simplify that equation, hopefully you got 1 over x plus 1 squared, and then equals 2/3. And then from here, we just need to solve this equation. Okay, so I'm just going to take the reciprocal of both sides. So take the reciprocal here. And the reciprocal on the right. And then I'm trying to isolate x, so I'm going to square root both sides. And so then x plus 1 equals plus or minus the square root of 3/2. So x equals -1 plus or minus the square root of 3/2. So now what I have to decide are both of these values on the interval from -1/2 to 2. So which, if not both, which is possible, are on the open interval from A to B. Okay. So it's possible that at least one of them has to be on the interval because that's mean value theorem, right? Mean value theorem guarantees that at least one of them is on the interval. But it's possible that both are on the interval as well, but we still have to check them. So in order to check them to see if they're both on the interval, we're going to figure out what is that decimal equivalent. So I'm just going to do in my calculator. And I'm just going to compute that. So -1 and then plus the square root of 3 divided by 2. So that would be 0.224. And then do the same thing again, but I'm going to do minus. And so -2.224. Okay. So if I look here, the -2.224 is too big, right? Because -1 or too small. So this one is not a solution, right? Because it's not between -1/2 and 2. So this one is not part of my solution. So therefore C, which is the value I'm looking for, is 0.224. And that is my answer. Okay, and then there is mean value theorem.